Till the last video, we have completed the NPN transistor. Today we are going to start the PNP transistor, and we will see the second point, that is second topic, that is current versus voltage relationship in BJT. Current versus voltage characteristic. Okay, so let's start the PNP transistor. I have drawn the circuit diagram. I have drawn the current flow in the direction for PNP in active mode. The NPN transistor and PNP transistor both operate in the same manner, but there are some certain changes that we will see what are the changes. But each and everything, the flow of current, the how it conduct, like emitter injection, hole injection, all are same. Okay, so let's start. In our NPN transistor, our emitter was connected to N side, N type of material, base is connected to P type material, and then collector is connected to the N type of material again. But in PNP, it is just the reverse one. What? Our emitter will connected to the P type material, base will connect to the N type material, and collector will connect to the P type material. So that's why the name NPNP, that is emitter base collector. Okay. Now we are going to deal in active mode. So in active mode for NPN, every time now in this video we will see the comparison. Because both are reasonable. Once you will come to know about one, that is NPN, you can easily write those points and everything about PNP. So it will become easy for you to compare both. So in our NPN, in active mode, how it was becoming active mode? When our emitter base junction, that was in forward bias, collector base junction, that was in reverse bias. Here also in PNP, for active mode, this same condition will be applied. Emitter base junction will be forward bias, collector base junction will be reverse bias. In that case, how it was becoming forward bias? It was before NPN. So N was connected to the negative terminal, P was connected to the positive terminal. Then it was becoming VBE, because base voltage is higher. That's why written as VBE. Here you see it is written as VEB. Why? Since it is P type material, for becoming this junction, emitter base junction into forward bias, my P will connect it to the positive terminal of battery. N side, N type of material, that will connect it to the negative terminal battery. Then only it will become forward bias. So here P will be connected to positive, N will be connected to the negative. It is also forward bias, it is also forward bias. So it is written VBE, it will be written as VEB. Okay, see the difference, VBE, VEB. Now, for the collector and base junction, that is CBJ, that will be in reverse bias. So in previous case, this base, which is P type, that was connected to the negative type of battery, and N type, that was connected to the positive terminal of battery. Then only it will become reverse bias, and it was written as VCB. Why? Collector is higher voltage than base. Here you see, here since it is N type material, this is P type material. How this will become reverse bias? When my N type will connect to the positive terminal battery, P type will connect to negative terminal battery. It means my base is higher potential, higher voltage than this N side. This P side, base is higher potential than collector side. That's why it is a VBC. VBC means VB minus VC. So now it will become VBC. VBC. Okay, it was before VCB. So this is the first point in the comparison between these two. Then we will see how the current flow, in which direction the current flows. In the NPN type of transistor, electrons that were injected from the collector side to the emitter side, and in that way the current was flowing from collector, one current was flowing through the base, that both are combining, and the current was flowing in this direction. This is IE. Okay. This is the base current, that is from top to bottom, and the emitter current right to left, and both are combining. It was moving in a direction towards right to left. This is the base current, this is the collector current, both combined. Here what will happen? The current will be in the opposite direction. Why? In NPN, electrons are injected, but in PNP, holes will be injected. We know our current direction is same as holes direction, and current direction is inversely proportional to the holes direction, electron direction. Okay, these are the directions. So electron will move from left to right, means current will flow from right to left. Now, what will happen here? Injected, what are the injected minorities? What are the injected carrier? That is nothing but my holes. Here holes will injected from emitter through base to collector. So the current in p-type material, that will be mainly depend upon holes. In the NPN, here the current was mainly depend upon the electron that are injected from collector to emitter, and there are some minority carrier holes also. Those are injected from base to emitter. Remember the NPN configuration. Here electrons are injected in PNP, but in NPN holes were injected from base to emitter. So because of holes some current was there, because of electrons some current was there. And in NPN the current was mainly because of electron, because number of electron was high. So here the current is mainly because of the holes, because here number of holes is very high and less number of electron is injected from base to emitter. So how this could be possible? If I will dope my base into a very less doping, if I will do less doping to this base and high doping to the emitter, then what will happen? Less number of electron will be injected from base to emitter, and because of that electron current, because of electron there will be some current, but that value is very less, and because of holes the current is very high. So in PNP my current is mainly because of electron, because of holes. Okay, in PNP the current that IE, small I capital E, small collector emitter current, that is because of holes, mainly because of holes. There are electron also, but here the emitter current was mainly because of electron. This is the first point. Now remember in NPN there are two components for the base current. One was nothing but the injected of holes from base to emitter, and as the electrons are moving P to N, there are some recombination. Because of that I have to supply more number of holes through this, and that's why my base current was due to two components. One, this is hole injection, and one after the recombination number of holes decreases. For that I was supplying holes, extra holes. So because of those two components my base current was generating. Here in PNP, in this case, here also my base current, that is mainly depend on two components. What are those? One is nothing but the electrons that are injected from N to P. Because of this electron there will be current in this direction. In base the current will in this direction, left to right. Electrons are injected from right to left. This is first component of the base current, that is injected electron. Because of this injected electron one current torque will produce, that is nothing but IB1. So this is IB1, which is because of injected electron. In the base there are also a second component. What is that? You see, as these holes are traveling from emitter to the collector, it is passing through the base. And if this is my base, this is base means N. So what will be the majority carrier, which is nothing but electrons. So the majority carrier electrons. Now holes are injected through the emitter to the base. So what happens? The electrons that are present near the boundary, they will recombine with the holes that are coming from emitter to the base. This is the holes that are coming from emitter, and these are the majority charge carrier in base. So they will recombine. As they will recombine, what will happen? Number of electron, that is number of majority charge carrier in base, that will decrease. But to maintain a circuit neutrally, maintain it, the number means charge carriers should be maintained. For that what I have to do? I have to add extra electron through this external circuit. Like in previous case, like in NPN, we are supplying extra holes through this circuit. Here we will supply extra electron. We will inject extra electron through this circuit into the base. Then what will happen? The number of electrons that are recombined with the electron, they are gone. But as I will supply maximum number of electrons through the external circuit, again it will maintain the same electrical neutrality, and the number of negative charge carrier will also increase. Okay. So because of this extra electron that is added through the external circuit, there will be another current, that is nothing but IB2, and that came because of recombination. Since recombination occurred, that's why I am supplying extra electron. If recombination was not the case, then already the same number of negative charge that are present in base, so no need to apply extra electron. Because of recombination, these electron will recombine with the holes, they become neutral, so the number of majority charge carrier decreases in base. That's why to maintain that I have to supply extra electron. So because of that extra electron, the second current that is coming IB2. So my total base current is nothing but IB1 and IB2. Okay. Now, similarly the graph that will, if you remember the graph that we drawn, number of electron decreases from emitter base junction to the collector base junction like this. This is for ideal case and this is for the practical case. Remember the previous NPN case. This was the case. Here this is nothing but my hole concentration. In NPN it was electron concentration. In PNP it is hole concentration. The hole concentration decreases and then they will come reach to the collector base junction. Now similar to the NPN, there was positive charge carrier and they were attracting the electron present at this emitter base junction to the collector side because of this positive charge carrier. In PNP, what will happen? Because of this negative voltage, negative potential, all the holes that are present at the boundary, they will swept to the collector side. They will not remain in the collector base junction, but they will swept to the collector side because of this negative potential that is applied. Okay, they will attract this negative potential, will attract this positive potential. This is nothing but my holes. So they will attract to the collector side. So because of these holes, they are attracting to the collector side. They are collected and they will give me a collector current. Similar to the NPN, electrons are attracted to the collector side, and because of that electron from base to collector, electron, my collector current was producing in this way. So here in PNP, the holes they are attracted to the collector side and the current will be in the same direction because hole current, because and the current direction and hole direction both are in the same. So these are the three currents that produced in our PNP transistor. Okay, and all the voltage and current relationship, like my IC, what I wrote, okay, for IC is nothing but Is e power VBE upon VT, that is in NPN case. In PNP, what will happen? It is same, but my IBE it will change to IEB. It is Is e power IEB upon VT. It is for NPN. It is for PNP. What is the difference? Here VBE, here VEB. Okay, VEB. So this is the one difference. Second, my IC, my IE, which is nothing but IC upon alpha. Alpha is common base current gain. Okay. So here also it is the same. My IC will be same IC upon alpha. Same. Everything will be same. But this alpha is for only NPN. So for PNP. Similarly, this criteria, this equation, current equation is also satisfied. IC upon beta. Okay. Everything that was present in NPN will be the same for this PNP, that is current equations. Also we will see in the saturation region, what we read in the last video, saturation region for this NPN type is same in the manner same as PNP. But wherever a VBE term is there, you have to replace VBE by VEB. Whenever a VCB term is there, you have to replace by VBC. Okay, because VEB and VBC both are for PNP transistor. VBE and VCB both are for my NPN transistor. Okay, these are 2 points. And the last point is that the circuit model that we drawn for the NPN transistor. If you remember that I drawn 4 circuit model for large signal, like this is base, this is a current voltage control current source whose value is Is e power VBE upon VT. This is my collector, and there is a diode whose value is DE and which has a current I equal to ISE, which is nothing but Is upon alpha. And this is my emitter. You remember that we did for this NPN transistor. There are similar to this, there are 4 circuit model. Here also in PNP everything will be same, but here the current that are coming IC, in this case current IC, this is the current direction, this is the IB direction, and both are combining giving me a current IE. Okay, these two will combine, give me a current IE. In PNP, what will happen? Just these two will interchange. Let me draw that one. Here there will be one diode. This is nothing but my E. Here there will be a current source whose value is Is e power VEB upon VT. You see the difference? In that case, my collector was at top. Now my collector is at bottom. Why? Because the emitter current is coming. It is dividing into 2 paths. This is the IB. You see the IB direction. This is nothing but the electron direction that is opposite to the current. Okay. So this is the IB direction. Emitter current is coming, it is divided into two parts, IB and IC. So here emitter current is coming, which is nothing but IE, dividing into two parts. One is IB, one is IC. And this is nothing but the same, ISC, which is nothing but IS upon alpha. Everything is same, but just we have to see the convention of current, that the current direction and the this voltage, battery supply, that they are changed. Okay, similar to this, there are other three diagrams that you can draw from the like NPN, you can draw for PNP. So this is for the PNP type PNP transistor. I am not going to describe all those points again and again. If in your question PNP will come, you have to write all those points that we read in NPN, same as NPN, but you have to change some point like this VEB, like this collector emitter change because of the current direction. Okay. Now let's move to the second topic, that is current versus voltage characteristic, and we will see the circuit model first of all. Okay. So these two, the A and B, these two diagram is forming the circuit symbol. This is the actual circuit symbol for a BJT. Okay, and these two are the circuit symbol for BJT with operating in active mode. Okay, so let's see some points on this circuit symbol. Whenever a BJT is given, you have to, whenever in a question it is there, you have to draw the BJT in this way. Okay, this is the circuit symbol, this is also a circuit symbol. We know our BJT, which is not a symmetrical structure. As I told in the starting video, in the previous video, that this and this and even though both are same for NPN transistor, this is emitter, this is collector, they can't be exchanged. For that reason, that for a non-symmetry, I have distinguished my emitter with a arrow mark. You see, this is also anti-material. This is also p-type. So this is also again one anti-material. But if I not place an arrow or any symbol, then how can I distinguish between emitter and collector? So to distinguish between my emitter and collector, this emitter and collector, I have put a arrow mark in collector. Always I will put a arrow mark. You see, this is nothing but my NPN type of transistor. This is nothing but my PNP type of transistor. Here also with emitter, I have put one arrow mark. Okay, always you put a arrow mark with emitter. Now, what does that arrow mark indicate? That arrow mark indicates or it shows the direction of current. If you remember in our NPN transistor, how our current flows? This is the IC, this is my IB, and both are combining, give me a current IE. Means collector current, base current, they combine together will give me a current IE. So you see, this is the IC, this is the IB, both will combine, they will flow in this direction. That's why this arrow mark is showing that the direction of current. Okay, so in NPN, the two combined will give me IE. Here also two combined and giving me current IE. Okay, you see, let's take this type, this NPN transistor. Let's take, this is my hand. Okay, and the fingers are nothing but my collector. And the center part, this center part is nothing but my base. And let's take the my wrist. My wrist is nothing but emitter. Okay, so this is collector, this is base, this is emitter. Now what I am going to do, I am taking this symbol into like this. So what does my fingers were representing? My fingers were representing collector. This center part was representing base. And the last part, my wrist, that was representing the emitter. So you see this diagram I have taken from here, I have put it here like this. So this is the collector which is at the top, this is the base which is at the center, and my wrist shows the emitter which is at the down or at the bottom. Okay, this is for NPN case. Similar for the PNP case, this is P, this is N, this is P. You can think in the same way. This is my PNP transistor, this is my collector, this is my base, this is my emitter. Now what I am doing, I am taking this symbol, I am taking this symbol and putting it like this. Okay, so my wrist, which is the emitter, which will be in the top, my base, that is center, and the collector, that is at the bottom. Okay, this is for PNP. Now in our PNP we know our current flow in this direction. This is the emitter current, this is the base current, this is the collector current. We have just seen some time before. So our emitter current will divide into two parts, IC and IB. Here you see my emitter current, that the direction is showing, the arrowhead is showing the direction of emitter current, that is divided into two parts, one is IB and one is to the collector current IC. Okay, so the convention is clear how they are representing, how they are represented, this NP and this PNP. Okay, now we have to take this NPN or PNP transistor, we have to operate in active mode. So for active mode, what are the conditions? Our emitter base junction, that should be in forward bias, in both cases that should be in forward bias, and my collector base junction, that should be in reverse bias. So you can check from here. Let's check first the NPN transistor. NPN transistor, my this is, I think this is PNP, this is VBE, sorry, this is NPN. Okay, VBE means it is NPN, VEB means it is PNP. So in NPN, our emitter base junction, that should be in forward bias. So this is N, this is N, this is P, this is N, emitter is N. So you see P type is connected to the positive terminal battery, N side is connected to the negative terminal battery. It means it is in forward bias. Here, this is the emitter. Emitter is positive, base is negative. It is also in forward bias. Okay. Now my collector base junction, that should be in reverse bias. So the N is connected to the positive, P is connected to the negative. So it is in reverse bias. It is PNP. N is connected to the positive, P is connected to negative. It is also in reverse bias. Okay. So in both cases, they are working in active mode. Means the biasing is done in that way that one will become forward bias, one will become reverse bias. One point you can also see, this always there is a voltage at the top, and the means positive voltage means it is showing the current flow in this direction. Positive voltage at top and negative voltage at down means it's showing the current that flows from positive to negative. Okay, here also the positive voltage is top, negative voltage is down, or here down. The current flows in this way. Okay. So what I mean to say, that for both cases you have to keep in your mind, this arrow mark should be put in that way, the actual direction of current flow, and always the battery voltage sources, there should be positive voltage at the top and negative voltage at the down. Now two more points you have to keep in your mind, that when this is PNP, when this NPN transistor will in active mode and when it will be in saturation mode. Active mode we have seen, these are the conditions when it will be in active mode. When it will saturation mode, for saturation mode this should be forward bias, this should be forward bias, but this value should be less than 0.4. It means, let me remove this one. Already clear you this two circuit model for NPN and PNP. So what I am saying now, when this NPN transistor will in saturation mode, that my emitter base junction, they should be in forward bias, collector base junction, that should be also in forward bias, but my VCB value, that should be less than or equal to 0.4, means VC minus VB should be less than minus 0.4, it is minus 0.4. Okay, or in a way I can say VBC should be greater than equal to 0.4. VB minus VC should be greater than equal to 0.4. Is it clear or not? I have already discussed this point. So this is the two condition. One condition is this one, that both will be in forward bias, and this is the second condition, that VC value 0.4. That is for NPN. Similar for the PNP, what is happened? The first condition is same. For the PNP also, this first condition is same. And the second condition, that is my VBC, that VBC value should be less than equal to minus 0.4. It means my VB minus VC should be less than 0.4. Or in other way, what I can say, my VCB value should be greater than 0 plus 0.4, or VC minus VDB should be greater than 0.4. Is it clear or not? This is for the NPN, and I have to take this point from here and I have to combine these two again. It will give me for the PNP case. Okay, don't confuse between VBC and VBC. You either remember this point or this point. Just remember one point that will be applicable to both. If you will take VCB less than minus 0.4 means for NPN, and for VBC less than equal to minus 0.4 for PNP. Okay. So this is the circuit model and the current direction.